Hi everyone, welcome back. In this video, we are going to determine and interpret the instantaneous displacement of a particle from its velocity and acceleration functions. First of all, let's check the first case. Let's say you are given a velocity function and you are required to find the displacement function. Then we have to perform an integration to get displacement function. S equals to integrate v dt. Let's check one example. Let's say we have v equals to 4t squared plus 7. To get displacement, we do s equals to integration of velocity function dt. So s equals to integrate 4t squared plus 7 dt. So after we do integration, there is a plus c at the back because this is an indefinite integral. Usually the question will give us an extra information to get the value of c. After you substitute the value of c into the equation, then only you will have a complete displacement function. Now let's check another situation. Let's say we are given an acceleration function from the start, and the question requires us to find the displacement function. In this case, we have to perform two consecutive integrations. That means, first of all, we have an acceleration function. Then from acceleration function, we can do integration to get velocity function. V equals to integrate a dt. After we have the answer for velocity function, we have to do integration one more time to get displacement. S equals to integrate v dt. Let's check one example. Let's say we are given a equals to 8t, and the question requires us to find the displacement function. So before you can find displacement function, you have to firstly find velocity function. V equals to integrate a dt. So in this case, we have v equals to integrate 8t dt. After we do integration, there is a plus c at the back because this is an indefinite integral. Let's say the question tells us when t equals to 0, v equals to 7. Then we just need to sub v equals to 7, t equals to 0 into the equation, and we will have a complete velocity function, v equals to 4t squared plus 7. After that, from v, if we want to find s, we have to do integration one more time. S equals to integrate v dt. So integrate 4t squared plus 7 dt. So same thing, since this is an indefinite integral, so there will be a plus c at the back. And let's say again, the question tells us when t equals to 0, s equals to 8, then you'll just have to sub s equals to 8, t equals to 0 into the equation. Then only you will have a complete displacement function. So in conclusion, from s to v, we do differentiation. From v to a, we do differentiation. If it's the other way around, from a go back to v, we do integration. From v go back to s, we also do integration. Let's try a few questions to practice more on this concept. Example 28. The acceleration of a particle is given by a equals to 4 minus 2t. Determine the instantaneous displacement of the particle when t equals to 3. So from a, if you want to find s, you have to do integration twice. So let's check. We have a equals to 4 minus 2t. When you integrate, you are finding velocity. So v equals to integrate 4 minus 2t dt. Okay, then there is a plus c at the back. Then let's check the first sentence. A particle moves along a straight line and passes through a fixed point O with a velocity of 12 meters per second. That means when the particle starts moving, it starts at fixed point O. Means when t equals to 0, s equals to 0, and v equals to 12. So among these three information, we take the two information that we want. That means when t equals to 0, v equals to 12. So t0, v12. After I substitute, I have c equals to 12. So this is the velocity function. And our purpose here is to find displacement function. So we have to do integration one more time. s equals to integrate v dt. After we integrate, we have a plus c at the back also. So let's check the first sentence again. When t equals to 0, s equals to 0. So we substitute. When t equals to 0, s equals to 0. So we have c equals to 0. So finally, we have the displacement function, s equals to 2t squared minus t power 3 over 3 plus 12t. And then let's read the question again. Determine the instantaneous displacement when t equals to 3. So now you just have to substitute t equals to 3 back to the displacement function. Okay, then we have answer s equals to 45 meter. Next, determine the instantaneous displacement when the particle is at rest. When the particle is at rest, that means v equals to 0. So let's check. This is the velocity function that we found. So we let it be 0. And then I rearrange the equation to become general form. So I bring all the term to the other side. We have t squared minus 4t plus 12 equals to 0. Then we do factorization and we will have two answers for t. T equals to 6 and t equals to negative 2. And time cannot be negative. That's why we put ignore for t equals to negative 2. Then let's read the question again. They are asking instantaneous displacement. So we have to substitute t equals to 6 into the displacement function. And we found displacement function just now. So we sub 6 here. Then we have answer 72 meter. Next, find the distance in meter traveled by the particle in the 7th second. Distance traveled in the 7th second means the distance traveled from the 6th second to the 7th second. So we have to do modulus of S7 minus S6. That means we have to substitute t equals to 7 into the displacement function. So this is the displacement function. We sub 7 here. Okay, minus S6. Since there is the word next, that means similar to hence. So you cannot find the answer for S6 all over again. You have to get your answer from the previous part. So S6 equals to 72. We need to minus 72 straight away. So in the end, after modulus, we have answer 4 and 1 over 3 meter. Let's try example 29. The acceleration of a particle is given by a equals to 6 minus 3t. Find the instantaneous displacement of the particle when t equals to 5. So from acceleration, if we want to find displacement, we have to do integration twice. So first of all, we have a equals to 6 minus 3t. We do integration to get velocity first. So v equals to integrate a dt. That means integrate 6 minus 3t dt. So after we integrate, there is a plus c here because this is indefinite integral. Okay, then let's read the question again. The information given is initial velocity is 3 meters per second. That means when t equals to 0, v equals to 3. So we substitute v equals to 3, t equals to 0. Then we have answer c equals to 3. So we have a complete v equation now. V equals to 6t minus 3 over 2 t squared plus 3. Okay, but what are we finding? We are finding displacement function. So we have to continue from velocity function. If we want to find displacement, we have to do integration again. So integrate 6t minus 3 over 2 t squared plus 3 dt. So after we integrate, there is a plus c again. Then let's check. The question say, a particle moves along a straight line and passes through a fixed point O. That means the particle starts moving at fixed point O. That means when t equals to 0, s equals to 0. So we can substitute t equals to 0, s equals to 0. Then we will get c equals to 0. So we have displacement function s equals to 3t squared minus half t power 3 plus 3t. Then we read question A again. They ask us to find the instantaneous displacement when t equals to 5. Because you finally got the displacement function, then now we can sub t equals to 5 into the displacement function. So we will have answer s equals to 27.5 meter. B, find the instantaneous displacement of the particle when its velocity is uniform. When the velocity is uniform, that means a equals to 0. So a is 6 minus 3t, we let it be 0. We have t equals to 2. Every time when we have one answer, we feel so happy, but maybe we not yet finished answering the question. So let's read the question again. They ask us to find the instantaneous displacement. So after we have the answer for t equals to 2, we have to substitute into the displacement function to get the instantaneous displacement, answer 14 meter. Example 30. The acceleration of a particle is given by a equals to 12t minus 8. Find the instantaneous displacement of the particle when its acceleration is 4 meter per second squared. So when you are given an acceleration function, you have to perform 2 consecutive integration to get displacement function. So we do integration step by step. First of all, we have a equals to 12t minus 8. When we do integration for the first time, we are finding velocity function. So v equals to integrate 12t minus 8 dt. After we integrate, there is a plus c here. So let's check the information given. Given the velocity of the particle, when t equals to 1 after passing through O is negative 10. That means when t equals to 1, v equals to negative 10. So we do substitution. T we sub 1, v we sub negative 10. Then we have answer c equals to negative 8. So this is the velocity function, but not yet finished because we are finding displacement function. So let's continue. From velocity function, when we want to find displacement function, we have to do integration again. So integrate 6t squared minus 8t minus 8 dt. After we do integration, there is a plus c again. So let's read the first sentence. We have a particle move along a straight line and pass through a fixed point O. That means when the particle starts moving, it starts moving at fixed point O. That means when t equals to 0, s equals to 0. So we substitute t equals to 0, s equals to 0. Then we will have answer c equals to 0. So this is our displacement function finally. Okay, then let's read the question again. Find the instantaneous displacement of the particle when its acceleration is 4 meter per second squared. So from this information, you have to get the value of t, then only can substitute into the displacement function to get instantaneous displacement. So a equals to 4. Okay, a is 12t minus 8. We let it equals to 4. We have answer t equals to 1. So we substitute into the displacement function. We have the instantaneous displacement s equals to negative 10 meter. For the working to find the value of t, it depends on you whether you want to do from the start or you can do like how I did here. After I got the displacement function, only I find the value of t. B, find the instantaneous displacement of the particle when the particle is at rest. When the particle is at rest, that means v equals to 0. We found v equation just now, 6t squared minus 8t minus 8. So we let it be 0. Then I divide every term by 2. So we have this general form. And then we do factorization. So we have two answers for t. T equals to negative 2 over 3 or t equals to 2. And because t cannot be negative, so we ignore this answer. So the answer for t is only 2. But the question is not asking about time. It's asking about instantaneous displacement. So we have to substitute t equals to 2 into the displacement function. So when t equals to 2, This is the displacement function. We sub inside, then we have answer s equals to -16 meter. Example 31. The acceleration of a particle is given by a equals to 10 minus 60. Find the maximum displacement of the particle. So this is similar to example 30, when you are given an acceleration function and the question asks you about displacement function, we have to do integration twice. A equals to 10 minus 60. First of all, let's do integration to get velocity function. V equals to integrate a dt. So for this question, V equals to integrate 10 minus 60 dt. After we do integration, there is a plus C here. So let's check the information given. They tell us initial velocity is 8 meters per second. So when t equals to 0, V equals to 8. So we substitute when t equals to 0, V equals to 8. So we have answer C equals to 8. So we have velocity function V equals to 10t minus 3t squared plus 8. But not yet finished. We want to find displacement function. So let's continue. From velocity function, if you want to obtain displacement function, you have to do integration. So S equals to integrate V dt. So integrate 10t minus 3t squared plus 8. After we integrate, there is a plus C again. So let's read the first sentence. A particle moves along a straight line and passes through a fixed point O. That means the particle starts moving at fixed point O. That means when t equals to 0, S equals to 0. So we sub t equals to 0, S equals to 0. Then we have answer C equals to 0. So this is the displacement function. After that, let's read the question again. Find the maximum displacement of the particle. So whenever you see the word maximum, means differentiation equals to 0. Maximum displacement means ds dt equals to 0. So ds dt equals to 0, and we knew ds dt is actually v. So v equals to 0. And you have your velocity function just now. 10t minus 3t squared plus 8 equals to 0. Since a is -3, so I bring all the term to the other side to get general form. And then we do factorization. So we have t equals to -2/3. Ignore because it's negative. And then t equals to 4. So we only accept t equals to 4. Okay, so the meaning of t equals to 4 is 4 is the time in which displacement is maximum. So to find maximum displacement, you have to sub t equals to 4 back to the displacement function. So we sub here, sub here, sub here. Then we have answer maximum displacement is 48 meters. Okay, you have already answered the question basically when you write until here. But to play safe, let's prove that the displacement is really maximum by doing second order derivative. Okay, so ds dt is actually v. We have this velocity function. Then d2s dt squared means you have to differentiate this function. So differentiate 10t, we have 10. Differentiate -3t squared, we have -6t. Or you also can think like differentiate v is actually a. So you can just take a and copy down here. Okay, there is still t in the equation. So we sub t equals to 4 into this equation. And we have answer -14, which is less than 0. When d2s dt squared less than 0 means s is a maximum. So you prove already that s is really a maximum. B, find the distance traveled by the particle in the 5th second. Distance traveled in the 5th second means distance traveled from the 4th second to the 5th second. That means we use S5 minus S4 modulus. So this is the working. S5 means we just have to sub 5 into the displacement function. So we have this. Minus S4 means we just have to sub 4 into the displacement function. Okay, then we have modulus of -8, and you will get +8 meters. Example 32. A particle moves along a straight line and passes through a fixed point O with a velocity of -12 meters per second and an acceleration of -10 meters per second squared. And then given that A equals to m plus nt, the particle stops instantaneously when t equals to 6. Calculate the values of m and n. A equals to m plus nt. Let's check the first sentence again. The particle starts moving at a fixed point O with a velocity of -12 and acceleration of -10. That means when t equals to 0, s equals to 0, v equals to -12, and a equals to -10. That means when t equals to 0, a equals to -10. So we do substitution. T I sub 0, A I sub -10. Then we will have m equals to -10 straight away. Okay, then I sub -10 back to the equation. We have A equals to -10 plus nt. Then let's check what else they give us. They tell us V equals to -12 when t equals to 0. To make use of this information, I must firstly have velocity function. So from acceleration function, let's do integration to find velocity function. So V equals to integrate -10 plus nt dt. After we integrate, there is a c here, so we do substitution. So just now we identify already, when t equals to 0, V equals to -12. So V, we sub -12, T, we sub 0. So we have answer C equals to -12. So this is our velocity function. In the velocity function, there is still n. So let's check, is there any other information that the question gives us? So let's check. The particle stops instantaneously when t equals to 6. When the particle stops means V equals to 0. That means when V equals to 0, t equals to 6. So we sub this information to this function. Okay, t we sub 6, V we sub 0. So in the end, we have answer n equals to 4. B. This is the velocity function. We found n equals to 4. So first of all, let's substitute n equals to 4 back to the velocity function. So we will have V equals to -10t plus 2t squared minus 12. Then let's read the question. Calculate the minimum velocity of the particle. When we see the word minimum, means we have to do differentiation and let it be 0. Minimum velocity means we have to do dv dt and let it be 0. So this is function v. When we do dv dt, it's actually a. So you can also substitute the acceleration function here. M is -10, n is 4. So a is -10 plus 4t, let it be 0. Then we have answer t equals to 5/2. So that means t equals to 5/2 is the time in which the velocity is minimum. So to find the minimum velocity, we have to substitute t equals to 5/2 back to the velocity function. So we sub here, sub here. So we have answer V minimum is -24.5 meters per second. Okay, after that, please prove that velocity is really minimum by doing second order derivative. So dv dt is a, and a is -10 plus 4t. Now let's do d2v dt squared. That means we have to differentiate -10 plus 4t. Differentiate -10, answer 0. Differentiate 4t, answer 4. So d2v dt squared is a positive number. That means v is really minimum. C. Calculate the total distance traveled by that particle in the first 9 seconds. So let's check. We found velocity function, but we didn't find displacement function. And the question asks about total distance traveled. So in your working, you can do integration of v straight away to get displacement function later. Okay. And then every time when they ask about total distance traveled, we have to firstly identify whether the particle changes direction within the period of time given or not. Then let's check the question. When a particle changes direction, v is 0. And the question told us the particle stops. That means v equals to 0, t equals to 6. So in this case, you have to do your integration separately. Integrate from 0 to 6 v dt plus integrate from 6 to 9 v dt because the particle changes direction when t equals to 6. Okay, so we substitute the velocity function here. And then let's do integration. Since this is definite integral because there are number here, so there is no plus c in the bracket. Okay, after I simplify, we do substitution. So 6 substitute into the equation, minus 0 substitute into the equation, plus modulus. So I still put modulus, 9 sub into the equation, minus 6 sub into the equation. So I have answer 189 meter in the end. Example 33. The velocity of a particle is given by v equals to 2t squared minus 5t minus 3. Calculate the displacement when the particle stops instantaneously. So we are given a velocity function and the question mentioned about displacement. So let's do integration to find displacement function. S equals to integrate v dt. So integrate 2t squared minus 5t minus 3 dt. We will have a plus c at the back. Let's read the first sentence. A particle moves along a straight line from a fixed point O. That means the particle starts moving at the fixed point O, means when t equals to 0, s equals to 0. So we sub this information into the displacement function. T we sub 0, s we sub 0, we have c equals to 0. So this is the displacement function. And then let's read the question again. Calculate the displacement when the particle stops instantaneously. When the particle stops, we have v equals to 0. Once we use this information, we will get the value of t, and then we have to substitute the value of t into the displacement function. So let's check. V equals to 0. Velocity function is given 2t squared minus 5t minus 3. We let it be 0. After factorization, we have t equals to 3. So now let's substitute t equals to 3 into the displacement function. Then we have s equals to negative 13.5 meter or negative 27/2 meter. So don't worry, s can be negative because displacement is a vector quantity. So this is the answer. B, calculate the range of time when the particle decelerates. Particle decelerate means a less than 0. But acceleration function is not given by the question. So we have to do differentiation from velocity function to get acceleration function. So we have a equals to 4t minus 5. Then from here, we analyze a less than 0. That means 4t minus 5 less than 0. So we have t less than 5/4. Then we have tried this many times. Every time when you meet this kind of answer, you have to write one more step. T cannot be negative. So that's why t is in between 0 to 5/4 and t can be 0. So this is the final answer. C, calculate the total distance traveled by the particle in the first 6 seconds. Every time when the question asks about total distance traveled, we have to firstly identify whether the particle changes direction or not within the given period of time. So let's check our working. Just now we did when v equals to 0, t equals to 3. That means this particle changes direction when t equals to 3. So that's why when you want to find total distance traveled in this question, you have to do two different workings separately. Do we have displacement function? Yes, we found just now. So we don't need to do integration here. Okay, we just need to do S3 minus S0 plus S6 minus S3 modulus. We do separately like this is because the particle changes direction when t equals to 3. Okay, then S3 means we just have to sub t equals to 3 into the displacement function minus 0 sub here, okay, plus 6 sub into the position of t minus 3 sub into the position of t. Then we have answer, total distance traveled is 63 meters. Example 34. Haikal placed a remote control car along a straight track. The acceleration of the remote control car is given by a equals to 12 minus 4t. Calculate the maximum velocity of the remote control car. So we are given an acceleration function and the question mentioned about velocity. So let's do integration to find velocity function. V equals to integrate a dt. So integrate 12 minus 4t dt. After we do integration, there is a plus c in the function. Then let's check. There is no information given about the velocity. So you can assume that when t equals to 0, v equals to 0. So we sub t0, v0. So in the end, we have c equals to 0. So this is the velocity function, v equals to 12t minus 2t squared. After that, let's read the question again. Calculate the maximum velocity of the remote control car. For maximum velocity, dv dt equals to 0. So we have dv dt equals to 0, and dv dt is actually a, and a is given by the question 12 minus 4t. So we substitute, let it be 0. We have t equals to 3. So t equals to 3 is the time that causes the velocity maximum. So now to find the maximum velocity, you have to sub t equals to 3 back to the velocity function. Okay, so we have 18 meters per second. After that, please prove that velocity is really maximum by doing second order derivative. So dv dt is 12 minus 4t. When we do differentiation one more time, we have answer -4. So less than 0. That means we prove already v is a maximum. B. Calculate the values of t in seconds when the velocity of the remote control car is 0. So this is a direct question. Velocity equals to 0. And we found velocity function just now, 12t minus 2t squared. So we let 12t minus 2t squared equals to 0. And we factorize out the common term t. So we have two answers for t. T equals to 0 and t equals to 6. C. Calculate the distance traveled in meter of the remote control car in the 5th second. Distance traveled in the 5th second means the distance traveled from the 4th second to the 5th second. So we have to do S5 minus S4 modulus. Okay, so for my working here, I try to get displacement function. Okay, we have velocity function just now. So to get displacement function, I do integration. Integrate v dt. So I have a function that consists of c. Then let's check the question. Haikal placed a remote control car along a straight track, and then this remote control car passes a fixed point O from the start. That means when t equals to 0, s equals to 0. So I substitute t0 as 0, I get c0. So this is the displacement function, 6t squared minus 2 over 3t power 3. And then modulus of S5 minus S4, that means we need to substitute t equals to 5 into the displacement function, minus S4 means we have to substitute t equals to 4 into the displacement function. So we have answer 40/3 meter. Okay, so this is one of the way of working. Another type of working is you can straight away do integration of v dt from 4 to 5. So depends on you which one you want to do. Example 35. The diagram shows Aslan running across a straight bridge in 25 seconds. His velocity after passing through M is given by v equals to 3/4t minus 3/100t squared. Calculate the value of t in seconds when the acceleration of Aslan is 0. So we are given velocity function and the question mentioned about acceleration. So first of all, let's do differentiation to get acceleration. Okay, then the question mentioned a equals to 0. So we let 3/4 minus 3/50t equals to 0. Then we have t equals to 12.5 seconds. B, calculate the maximum velocity of Aslan. For maximum velocity, dv dt equals to 0. So I write dv dt is 0 and dv dt is a. So a equals to 0. And then let's check from part A, we have already identified when a equals to 0, t equals to 12.5. So that's why I state 12.5 here. And the meaning of t equals to 12.5 is 12.5 is the time in which the velocity is maximum. So when we want to find the value of maximum velocity, we have to substitute t equals to 12.5 back to the velocity function. So that's why I sub. Then we have answer maximum velocity 75/16 meter per second. And then please prove that the velocity is really maximum. So to do so, we have to do d2v dt squared. Then let's check. This is v and a is actually dv dt. So we have dv dt equals to 3/4 minus 3/50t. And now we have to differentiate this function again. So d2v dt squared will be negative 3/50. So I write down negative 3/50 less than 0. That means we have already proved that velocity is really maximum. C, calculate the total distance traveled by Aslan. Let's check the question again. Aslan ran across a straight bridge in 25 seconds. If you want to identify whether Aslan changes direction or not before 25 seconds, you can do v equals to 0. So this is v. I let it be 0. Then we factorize out t. Then we have answer t equals to 0 and t equals to 25. That means before 25 seconds, Aslan didn't change direction. So that's why when you want to find total distance traveled, you can integrate from 0 to 25 straight away. Okay, then let's check why I do integrate v dt here is because we didn't find displacement function just now. So without a displacement function, if you want to get the total distance traveled, you can do integrate v dt straight away in your working. Because after you integrate velocity function, it will be displacement function. So I sub velocity function inside. We do integration, simplify, and then sub 25 into the function, minus sub 0 into the function. Then we have answer 625/8 meter.